Welcome again to the system sizing. This is part 2 of the review video on plan electron installation work. Like I have said in the previous video, after the survey report, now you have to draw your information to here. Having circuits, and these circuits, sizing these circuits with respective cable size, respective protective devices, and if possible, going ahead to create now a list of material for each circuit. That's what designing is all about. So whatever we are doing here, we are designing. Then part of this designing also involves preparing the layout diagram as well as the wiring diagram. And as we proceed with the designing, we also have to come up with a list of material. That one I'll be doing in the next video. But for this case, we are going to sizing. But before you continue, please subscribe below and give a comment. Like if you like this, give us your view, what you think we can improve on next time. So I'll be taking you through the sizing, and in this case, we have, like I said, we have 5 circuits. Now these circuits we have generated from the site survey report that we conducted before. So in this case, we are going to have lighting circuit, and this lighting circuit, I intend that all the lights to be protected with a single protected device. And in this case, I'm choosing to use circuit breakers. And to be specific on the type of circuit breaker, I will be using miniature circuit breaker, the MCB. And to be even specific on the type of MCB, I'll be using type C, because those are the ones that are common. We understand we have type B, type C, and type D miniature circuit breakers for domestic purposes. So, in this case, the first step while you're designing or you're sizing the system is to understand the load. So the load estimate, you're going to calculate the total power. Remember, every appliance or accessory has been given rating. So we're going to apply power in that case. So I'll be going on my end. So we have 2 ceiling layers rated at 100 watts. So then we are going to add 12 volt brackets rated at 18 watts. And then we're going to have 4 single fluorescent lamps rated at 45 watts. Then we are going to have again 1 double rated at 60. Then we are going to add 2 backlights. This one was for the washroom times 18 again. Then plus 5 security lamps, which are rated at 25 watts each. So all these should be able to give me a rating. So that in that case, let's mark it quickly. So this will be 200 times 216, that is 216. Then plus 90, that's 180. 180 plus 125 plus 36 plus 60. So the total power load for the lights is 817 watts. So that's what the load or the cable should be able to carry to this. So from this load estimate, we proceed to what we call design current, calculation of design current IB. Design current IB is calculated just directly from the Ohm's law approach. That will be power over voltage. And even if you're using maybe appliances that have power factor, in that case you have also to say voltage times power factor. So for this, I just be saying that will be 817 over phase voltage. In our country Kenya, the phase voltage is 240. In other countries it varies, so in this case we're going to use 240 volt. So my current in this case would be 3.4 amperes. So that's the design current. So this one, we proceed to the second or the third part, which is now to select the appropriate protective device rating. And I've said you're going to use circuit breaker type C. So in this case, I select the one that is closer to this. And the next circuit breaker, that is IL, that's closer to 3.4, is 6 amp type C MCB circuit breakers. So in that case, the select nominal setting for this circuit is 6 amperes. And like I've said, my set conditions were not that special, so there were no rating factors in this case. So I have to assume that this same 6 amperes is the one that I'm going to use to decide on my tabulated current capacity. So since there are no rating factors. When I say rating factor, I'm referring to correction factors. The C, Ci, Ca, Cda. So since there are no, then my IN is my IT is equal or greater than IN. And the IT is what is on the table reference. So since we are using single core cable from the recommendation done on the survey report, we are going to use single core cable. We are going to use the table in IE regulation, and the table should be the one that is for single core thermoplastic, that is PVC cables and anything that is not special cables like the MI6. So we're going to use that table for single core thermoplastic. And remember, we had also recommended the installation method. So in this case, it's reference method A. So from there, you should be able to go and get for single core cable single phase. And I'm so sure when you're looking at it, you should get a cable size or a conductor size (1.5 square millimeter). That's what you should get. In the previous video on sizing, I was able to give you a table and even how to trace the figures. So that's how we do it. So with this, now you can go ahead and even calculate what you call voltage drop. But since this is a small cable, I understand that the voltage drop, it gives allowance of even more than 100 meters run for the conduit. So that case will not be a problem. But in order to proceed with this, the second part of the table, you should be able to calculate the voltage drop. For today, I'm not be taking you through the voltage drop. I just need to take you through the corporate part of it that we need. So from this designing alone, we have known the size of the cable, we have known the size of circuit breaker that we are going to use, and we know the accessories that we need. So if a ceiling, we need the ceiling. With the old brackets, we need that. So as we proceeding to material listing, we'll be taking the items as rated. Let's quickly go to the socket outlet. This one is very different. The approach of this one is different. We already have been given the design current from the manufacturer. So you don't need again to go and start calculating the design current. So the guide for this usually is the flow area that guides us and how, or the method of installation that you're going to apply it. So the wiring system, I mean. So if you're going to connect your sockets in ring in this case, and the house area does not exceed 100 square meters, then one ring circuit is enough. But if you have to use radio in this case, it's only one way, then you have to use up to a maximum of 50 square meters for one circuit breaker. So the moment you exceed 50 square meters, you need another circuit breaker for that. But let's go the flow area that was given, and the fact that I'm also isolating one twin with this circuit, the flow area does not exceed 100 square meters for that building in this case. So I'll be using a ring, and if you have to use a ring, then it's recommended, if I'm using this single core cable, it's recommended that I use that 2 ampere MCB, if it's MCB, and this is type C. And then alternatively, the conductor size is 2.5 square millimeter. In that case, all the sockets, and I mean all the socket outlets, which is the 10 twin socket outlets, 13 amperes, and these two single socket outlets, which is 13 amperes. So the 12 sockets will be connected on a 13 ampere MCB, and will be powered with the conductor size, which is 2.5. Remember, we have said that when you're using the line neutral, then the earth or the grounding, the CPC, is is allowed that you can go a little bit lower, but in Kenya we usually just use all the sides, same for safety, because the earthing should also be so sensitive and also effective. But in other countries, or it's also recommended that if you use this cable 2.5, then the earthing can also be 1.5. If you're using this 1.5, then the CPC can be 1.0. So that one can still work. So this one will be for the 13 ampere 240 sockets. And then for this one that is 20, then for the 20 I can just use 20 ampere MCB for 20 ampere 240 socket outlet that will be placed in the kitchen. And the cable size should also be the same. So in this case, because this one can be connected with the radio, so this one will be green, then this one will be radio. In that case, the cable size is 2.5. To know more about this, please go and get this book here. Remember I said that this book, the wiring regulation book, is an additional book that gives you a regulation that is. You can also get more from the Kenya Power Bylaws. You can get more on IE regulation. It states a lot on the regulation. So when I keep on saying it's recommended, I'm referring to the regulation that guides us in this field of installation. So don't do it blindly. These figures are not coming from heaven. Let's go to the cooker circuit. Here I'll also be following the approach that I followed with the first one. So we go to getting a power load. We have been already given the power load that is 12 kilowatts. So that's 12,000 watts. So the power for the circuit is 12,000 watts. So you proceed to design current. The design current will be 12,000 over 240. That is 50 amperes. But now when it comes to cooker circuit, we have something called diversity. So the diversity, getting at 50, maybe circuit breaker, 50 circuit breaker, it means that whenever the cooker unit has a fault, or the circuit breaker will still be on, sense that everything is normal. So when it comes to this, we have a diversity that you're not going to be using a cooker for a long time. We usually use a cooker for a short time. So in this case, we have another formula that we use it. And this is the approach. So with the cooker unit with socket outlet. So we use this formula. We take 10 ampere from what we have, and then we add 30% of remaining. And then since it has a socket outlet, if the socket outlet is maybe 5 ampere, because the socket outlet attached to the cooker usually rated less, but in most cases I've seen others rated at 13 amperes, but in most cases it's 5 amperes, so you add 5 amperes to the circuit outlet. But the one without, it will be just 10 plus 30% of the remainder. In that case, I may proceed to number set. So for this case, it's one with circuit outlet. So it will be 10 amperes plus, what's the remainder from 50 amperes? It's 40. So we are going to do 30 over 100 of 40 amperes. Then once you get that, add 5 amperes. So quickly, when we do this will be so 30. That will be 12. 12 added to this, then that will be 27 amperes. That is 22 plus 5, that's 27 amperes. So that's our diverse design current. If it was for the one without cooker socket outlet, I'll show you when I'll be dealing with the materials later in performance installation. I'll show you how it looks like. So it will be just 22 and not 27. So then I proceed to selecting the nominal setting or the appropriate protective device for this. And since we have chosen to use type C MCB circuit breaker for this case, then that one, the one that is close to this will be 32 ampere type C MCB short. And then when you go, as I've said, there's no nominal rating in this case, so IT is greater than or equal to IN. So you go and check in the same table, you go check for the 32 ampere or something that's closer to this, but not lower than that. So in this case, I link it together. This unit will be either using 4 square. In that case, I don't think it will be 6. That should be the size of that cable. So the cable with 4 square millimeter single cable should be appropriate for this. And the same we proceed quickly to instant shower. You can see here we have introduced this new thing called the diversity. Diversity factor. It has there are certain things that have diversity factor. This one goes even for discharge lamps and all that. So for instant shower, it's simple. So we have 2 instant shower, all rated at 18. So power, total power, in this case is 2 times 1800, which is now 3600 watts. So we proceed again to IB. So IB, that one will be 3600 over 240. That is 15 amperes. So the design current is 15 amperes. You go for nominal setting IN. The closest, the one that is closest this, that one should be 20 ampere. 20 ampere. No, we have 16 ampere. So we have 16 ampere. Type C. MCB. Remember also this one I'm not guessing. This nominal setting, this rating of this type of circuit breakers are already in the market. So if you are not, just go and Google the rating of the MCB circuit breakers, depending on the type. So you get all the ones, rating and all that, and all effect on that you need to do with it. So don't relax, it's time to get it. So the cable that should be associated with this kind, still I can use 1.5 to be appropriate, but we can also use 2.5, because if I was using, in this case I was using 1.5 for 3.4, then again I come and use 1.5 for 16 amperes. It does not even make sense. So if we can go and use the cable size, which is 2.5 square millimeter, and I make sure I reduce the distance as far as possible, so make the one that is so closer to this. So in that case, I proceed with it. Now when we go to the air conditioner on the other end, which is also similar, the same applies here. So the air conditioner power is 300, so IB, or the design current, will be, so in this case will be 3000 over 240, and in that case 12.5 ampere. So the suitable circuit breaker in this case, which is type C, to be 16 again. Remember, from 10 it's 16. So we cannot go to 10, we go to 16 ampere MCB, which is type C. Being specific so that when someone goes to get material, you'll be able to check against what it is. So that is it. The same applies. Instead of using 1.5, you can use the cable, which is 2.5 square millimeter cable. That one means that everything will get power as it is. So from this point, we can go ahead and size our consumer unit. So the consumer unit, this is how you proceed with consumer unit. First, you need to know how many circuits are there. So in this case, we have a circuit for lighting. So we have lighting circuit. And lighting circuit, we understand the consumer control unit, the CCU, houses circuit breakers. So the lighting circuit would have 6 amp circuit breaker. We have power circuit, which has 2 circuit breakers. We have 32 for the ring, and we have 20 for the radio, which is the socket outlet in the kitchen, the 20. And then we have cooker control circuit, which is also 32 ampere. And then we have instant shower circuit, which is 16 ampere. Then air conditioner, also 16 ampere. So you can see all this. So these are 6 circuits. So our consumer unit, before we even go and proceed with the main circuit breaker, so we know that we need a 6-way consumer control unit. So when you're going for the one, you're going for 6-way consumer control unit. Anything beyond there, you'll be going for a distribution board. So that's how it is. So how do we go ahead and calculate the design current for the consumer unit? We just add all the design current. The design current, not the protective current. So what was the design current for the lighting? That was 3.4. Then come add for the power. Where the power we have 13, so the highest is 20. So we go with the 20. Then what was it for the cooker unit? The one that was standardized, that is 27. And then you come for this one, you have 15. Then we have 12.5. So when you do the sum of all this, you should get so I'm getting that's 30. So I'm getting 77.9 ampere. So you can see. So in this case, you're not going to support. In most cases, people just use 63 amperes as the double pole circuit breaker for this case. But this one, you see, the total design current exceeds 63. So you can go ahead and use 80, or even use 100 for effectiveness. So if you're using 100, it means that everything will be supplied with it. But now the problem comes from the issue of safety. But if you use 80, it will be even more effective, because whenever there's an issue and all the circuits are on at the same time, the circuit breaker should be able to trip and cut off the supply. That's why the converters are all. So you can see, we know we need a consumer unit with 6 slots and also an ample rating of either 80 amperes, MCB, also type C, and then the conductor size. For this case, you go for the conductor size. So conductor size, for this case, when you go and check, I'm so sure you're going to get something above 6.0 square millimeter, because you still go on the same. You're using single core cable, and this case is thermoplastic and for single phase. So if you're in reference method A column, you're likely to get either 6.0 square millimeter, or if not that should be 10 millimeters. So that is the cable that will run from the meter box to the consumer unit. So get the cable. So for this case, let's use 6 millimeter for the sake of learning. So once you're done with this, you have done what we call sizing. You have done what we call sizing. So you can go and check on the issue of voltage drop, and this one can be minimized by making sure that you use the shortest distance to reach the appliance or accessory from the consumer unit. And the same way, the consumer unit should be also closer to the meter box. Avoid a lot of power loss and making a lot of energy charge on the client. So for this case, I'll end at this. We are going to proceed from this point in the next video to material preparation. Stay put.